This talk is a part of my history as a freelance, a project I've worked for a couple of weeks. Let's say that way. Here's how it started. And this is literally how it started. I just got an email from someone I knew from a company, and he said, hey, we want to build our own Kubernetes developer platform internally with everything. It was almost like the Christmas tree. So we want it to be fast, secure, scalable. We want to move very fast, and we want to have it on-premise. And on-premise, in this case, is probably the most important part of the story. I'm Rachid Zarouali. I'm French, actually. Freelance cloud architect, 7 Sphere is my own company. My day-to-day job is basically building tools and platforms for developers to consume as easily as possible. Literally, if the teams I'm working with can leverage what I'm building with a single Git commit, that's what I'm paid for, more or less. So how do we start it? So this company knows most nothing about infrastructure as code, so plain ClickOps portal and click and click, but they had a very deep and solid Kubernetes expertise, no resources, and they have their own OpenStack that was building up. And the whole story was, you have to cope with all of these rules, if I can say that way, and help us achieving our goal. My first step was to understand what really means we want to go fast, we want to be secure, we want to be highly scalable and on-premises. So what I did at first, I'd simply cut the whole thing in pieces. Fully open source, that's my core. I don't work with proprietary solutions. I always offer and suggest open source solution. That was perfect. Hyperscalable is everything and nothing at the same time. It really doesn't mean anything. The main idea was we just want to be able to deploy several instances of our developers' Kubernetes clusters at once, and we want to be able to destroy them at once. That was the overall idea. The other point is probably the most challenging. Fast, for me, was at first, we want to have something that is highly performant. In their head, fast meant 3 weeks. So I literally had 3 weeks to do the R&D, build the platform, test it, secure it, ship it, train people, and put it in production. And on-premises, which is another challenge in a way that I can't leverage any cloud provider. So all the tools that you can have with all the cloud providers that we know was cut off. A couple of goals that I made myself for me to make it, how can I say, easier. I really wanted to be simple for developers. Even though those developers knew about Kubernetes, how it works and it's internal, that wasn't the case for the whole team. So we have different level of expertise in the team. And I really wanted to have something that is as easy as possible. As I said, a single Git commit should fit each and any developers depending on their needs. I made it, or I thought about it being as extensible as possible. You don't have to have a single monolith platform. You should be able to have as many add-ons as you want, change one block to the other, replace the ingress by another one, choose another storage interface for another one, again, without having to dig in. Fully open source, again, I'm really into it, and there's just no way I would, how could I say, go into, oh, I'm sorry, but for this project you have to pay. So I thought about, what if we could use Kubernetes to drive Kubernetes? We know how to deploy Kubernetes clusters. I think there's more than 100 ways to deploy Kubernetes clusters with Terraform, Ansible, binaries, the cloud provider's way, all the distributions that you can find. And as those people knew a lot about Kubernetes, I was really into, let's think about using what you know best to fill in. Again, I'm hammering this because that was for me I really can't say it clearly. That wasn't a nightmare, but that was really stress. And let's figure it out. Let's see how you feel about it. That was my first reaction. Honestly, I just get a phone call. I was like, I'm sorry, 3 weeks, you wanted this and this and this and this. I can't make it. And we just had to settle down a little bit and say, okay, let's chill, think about, do your R&D, and then we decide. How I fixed it, or how I tried to fix it, you will probably discover that there's some glitches in a way. First R&D, I discovered, back in that days, that again, there was plenty of solutions to deploy Kubernetes clusters, but there's also plenty of solutions that exist to automate Kubernetes deployment. Some were stable, some were into a specific solution tied to OpenStack, for example, or something that has been built on top of Gardener. Some were tied to the Rancher platform, and so on and so forth. And the main point was find something that is evolving as stable as possible, again in 3 weeks, without having to lock them into a solution that they will have to probably drop in 2 or 3 years. Again, make it flexible, make it composable, and make sure that if whatever happens for the project that we choose, they can either move to another one without rebuilding everything, or simply doing their own evolution. And it probably doesn't seem that way, but that was another challenge in the fact that most of the solutions that you have in these slides back at that time wasn't stable at all. Most of them were like, oh, we want to do something with Kubernetes. We thought about probably building Kubernetes on top of Kubernetes. We try something and let's see. Yeah, breathe. And that's what I'm doing. Breathe because I was in front of 30 different solutions, their own implementation, their own roadmap, no clear expectation about if I would be really able to leverage them in the topic, or if I can contribute to them to make it work for my client. So again, another round of R&D, testing, building, breaking a lot, and then move on. In the end, my suggestion for my client was, okay, this is what you're doing right now on the left. So basically, you are building your own Kubernetes one by one. This probably doesn't mean a lot to you, but let me explain it a little bit more. What this means on the left is, for example, upgrades mean you have to upgrade each and any of them one by one. Depending on the number of nodes or the complexity of the cluster, you have to go through the upgrade process one by one. If you follow the Kubernetes upgrade path, it could be, let's say, simple. But if you miss one of them, then that means that for each and any of these clusters, you have to go through 1, probably 2, at least 3 upgrade paths. I have it in another professional experience, and for 40-ish clusters, it took us 3 weeks. 3 weeks, 3 people just doing upgrades. This wasn't at all the case. So we moved to, okay, we have a solution. We will create a seed that you have here on the right. A single cluster that has the ability to deploy, manage, destroy, upgrades, but also deploy applications on top of it. From a very single point of view, from a central Kubernetes clusters, you don't have to connect to 10 or 20 clusters. Just connect to this central one, throw your upgrades, and there's some magic in between, we will dig into it afterwards, that does this for you automatically. Go through each and any clusters, looks at the version, takes the upgrade path automatically, do the upgrade, checks and passes from one to the other automatically. So without moving from 3 weeks to literally, as a git commit. So you just do your git commit, you go have lunch with your colleagues or your family or whatever, just to take 1 or 2 hours and be back at the office, and the full upgrade is done. We wanted to have, again, something that allow us also to deploy application on top of those clusters, but the overall idea on top of it was, let's say, for example, I'm deploying WordPress, so the famous CMS that we all know of. We didn't want it to have to go through each and any of those configurations and say, hey, would you please deploy WordPress on top of all of them? We wanted, again, to have something as a git commit. I want to deploy WordPress on cluster A, C, D, F, Z, blah, 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 and do it. To achieve that, there's a project which is called CAPI, ClusterAPI. Who never heard about the ClusterAPI project? Please raise your hand just to know. You're in the right place. And I am too. That's good. ClusterAPI project is basically Kubernetes with Kubernetes, or Kubernetes deployed, created, managed with Kubernetes, plain objects. What we able to achieve with my turtle friends here is to use a single Kubernetes cluster to deploy those clusters almost anywhere in the world, almost. So you have the ability, you have a tool, a set of tools, actually, that allows you to deploy those clusters on Azure, Amazon, Google, VMware, OVH, Scaleway, Exascale, whoever. As long as there's a provider that has been built for the CAPI project, you're able to deploy it. Another great feature is you're not tied to one provider, meaning for my A, B, C, D, E, E, F clusters, I can say AB is on Amazon, CD is on Google, DE is on Exascale, and XYZ is, I don't know, Scaleway. I can split them. These projects also allow us to move clusters from one provider to the other. And this was very interesting for me in this project and in another I've been working on, in the way that allows your company, client, team to start somewhere internally with your own platform, probably based on OpenStack, and then move it elsewhere without having to rebuild everything. It is mainly changing couples of objects in your manifest, and that's it. And this magic tool, CAPI, will literally, automatically move your cluster from your local OpenStack platform, for example, into, I don't know, Google, AWS, whoever you want, automatically. Internally, how it works, let's move it out. Briefly, this is the raw view of this project. What's really interesting here is everything is managed by a new Kubernetes object, which is the cluster object, and this cluster object has his hands on everything. The part that manages your infrastructure, so where you deploy, is the infrastructure cluster, and this is where you will decide, I want to move to Azure, I want to move to OVH, I want to move to Scaleway. You have the ability to change the Kubernetes distribution that you want. You can go from pure vanilla to K3s, K0, COPS, whatever. All by Kubernetes itself, with all the components baked in, and allows you to also leverage all the default Kubernetes features. Multi-tenancy, RBAC, security, and so on and so forth. How it works? Very, very, very simple. This is us on the left. We just create a YAML. I will try to show you some of them if I have a couple of minutes. Those YAML, you give them to the management cluster where you have CAPI and all this toolkit, and that's it. Basically, kubectl apply my very shiny YAML, and that's it. And it will deploy on wherever you want. In our case, it was OpenStack, but again, do it everywhere. There's something that's coming up being stable, not really stable, at least for me, is the ability to also mix. Mix in this case, and I think for some companies it could be interesting, is, for example, you could have your the masters on AWS because it's cheap there, and the workers on OVH because the workers are cheaper on OVH than on AWS. You can literally move your nodes everywhere, again, just by doing a simple YAML. Technically, how it works and how is it for us? Two things to keep in mind. V1 Alpha 3. If you know about Kubernetes, the alpha versions means breakage on each and any version. Could also mean a full rewrite of the whole specification without anybody asking you if they're allowed to. They will just do it because they wanted to. That was the case in my project. And as you can see, I have new kinds. We all know about deployment, namespace, pods, storage and stuff, persistence, volume, network, all those kinds. And now CAPI adds new objects into the Kubernetes features. We now have clusters, which is the base, the umbrella. And this umbrella manages different. The kubeadm control plane is where we will deploy the control plane. Where, how, why, with what, and which Kubernetes distribution. And the infrastructure is where we will manage the workers, where your application will really be deployed. In our case, in the case on this project, it was an OpenStack, but again, just depends. Those kinds are Kubernetes objects. So when you deploy your cluster with the ClusterAPI product, you can do kubectl get clusters, kubectl get OpenStack clusters, and it will tell you what you have, what has been deployed, when, the status, health, and so on and so forth. How do we move on? Very, very, very easily. Start with your own laptop. That's enough. Kind is very enough. You just deploy a small kind cluster, and that's it. Deploy the ClusterAPI toolkit. There's a tool for that, ClusterCTL, that does all the magic for you. You can also pass to this tool the add-ons that you want to use. I will show you a couple of them afterwards. And that's it. Just a kind cluster, kind create cluster, easy. Kubectl init, easy, done. You have your ClusterAPI pre-seed cluster, so the, how do I say, where you cook your instance locally without anything else. Moving on, create now the real cluster, which for me is where you will really deploy your production instances. You don't necessarily have to deploy only one. For example, for a huge platform where you have thousands of clusters, it makes sense to have multiple seed clusters, just to spread the workloads and have something that is more flexible than one huge cluster that manages thousands of, which also could have some issues. And once this cluster is done, move. I have cooked my platform locally. I have prepared my production seed cluster. I just want to move what I built locally to the destination. And there's a command for that, kubectl move, and we'll literally move everything. So it will reinstall all the components with the right version, move the configuration, connect to the managed clusters and so on and so forth. And your seed now will be self-managed. It's yours, real one, and now you're able to create your clusters. Boom, do it. Either you want to use plain YAML, that's what we use at first. You can use Helm, customize whatever the templating engine you want to use. You can deploy multiple clusters at once with several regions, whatever. Again, fully centralized. Just a quick example from the OpenStack provider. As I said, this is an OpenStack machine template, so we define what's the image that we want to use for all the nodes in the sense of this class, in the sense of this project. I have, let's say, put aside couples of details here intentionally, but This is the raw idea. What I haven't been speaking about is a lot of details that you have to work on in the background. This image is a default one, but you can create your own, push it, and reuse it. You can extend the configuration of the nodes that you want to deploy using Cloud-Init or Ignition, depending on the version of the operating system you're using. You can create your network out of it. You can create your load balancer on top of it. Everything, again, baked in into the ClusterAPI. Basically, what we leverage with the ClusterAPI project is what we call cloud controller managers built for the platform where you want to deploy your clusters. And those cloud controller managers offers you all the features that you want to leverage. Security, networking, storage, load balancer if you want to use them, identity if you're on, I don't know, the cloud provider and you want to connect to the central IAM, whatever. Again, everything baked in. And we're almost there. I mean, at that time, I think I was like two weeks in the project's length, and I was almost there. We had our first clusters deployed automatically, and it was working, and it was fine. But there was way too many manual steps. It was developer-friendly. They knew Kubernetes. They know how to write YAML. They had their templates. That was fine. It was highly extensible. You can add all the add-ons that you want to play with, fully open source. But it wasn't really simple to operate in a way that it was manual, manifest, pushed into a Git repository, and then applied manually. So we wanted to move forward and go into GitOps. Again, single Git repository, use ArgoCD, create your application set. Argo pulls the information from your Git repository, syncs automatically, done. Upgrade, create, deploy. Package with Helm or customize with whatever. We used Helm back at that time because I wanted to. But this allows us to train the developers into, here's the Git repository, here's where you would put your values from the Helm for the Helm package. Just change those 3 values, the version of Kubernetes, the number of nodes, and the flavor that you want to use, and that's it. And you can even deploy 10 clusters at once if you want. 3 minutes job, git commit, go have lunch, done. Easy. Sorry. Why ArgoCD or Flux is the same? We wanted to have continuous reconciliation mechanism, not from the CAPI project, because the operator does it for you, but from the whole management system. We really wanted to avoid someone that says, hey, I have access to the seed cluster, let me kubectl edit cluster, blah, 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 manually, and then change it, and then boom, your production is done. We really wanted to have something that have several guardrails of controls, and allows us to say, oh, no, this is not the appropriate configuration. The appropriate configuration is from the Git repository. Let's get the Git repository deployed. I told you I had some challenges on this project. These are a couple of them. I have one story. I don't know if it's fun, but it's real. I was working on this project, and so I discovered that I had to use a non-transparent proxy. The ClusterAPI at that time, or Ignition at that time, wasn't offering that kind of feature, so I have to find a way to push those proxy configuration. I discovered that OpenStack was deployed, meaning going through the official documentation, and that's it. Nobody really knows how it works, how to manage it. Probably now the fun point, really not at that time, is I discovered that I have limited internet access. Even worse, I was working for them for, I think, let's say since 8 a.m. in the morning. And the connection to the platform cut. I wasn't able to manage or do my job through the VPN connection. So I just gave a quick chat about, hey, what's going on? And someone told me, I'm sorry, we have a sandstorm. And I was like, what's the relation between my internet connection and the sandstorm? It's, okay, you have a sandstorm, that's fine. And it was like, yeah, but the platform you're working on is using radio internet connection. So if there's sandstorm, rain, or even winds, you're cut off. Yeah, but I have to download around 10 gigabytes of files, so what the heck? So what happens in Europe, and that takes 10 minutes, took me 4 days. And again, I had 3 weeks. And I also discovered that documentation is really not our best skills as developers. We're really bad at it, and we will always be bad at it. And this project was really, at the time, bad at it. So there was a couple of undocumented features. Some features were documented as stable, they weren't. I had some Go issue where you look at the logs, and the logs nowhere tells you what really happening. You just have to guess that, oh yeah, I just changed this line, and this line has a space. And what's the relation with the space? And someone tells you, yeah, but you know, the way we build the operator and how it works, it's really, really strict. So if there's a space in between, it doesn't work. Yeah, but this message doesn't tell me that there's a space in between. And the guy was like, yeah, no, we have to fix it. Again, 3 weeks production. In the end, I succeed. 1 Git commit, 1 or many clusters, automatic reconciliation, remediation through ArgoCD and Helm, Kubernetes, drive Kubernetes. I was able, in more or less 3 weeks, let's be honest, not really 3 weeks, probably 4-ish, a portable Kubernetes as a platform project. And they were able to use it internally on their OpenStack and elsewhere. But I'm not the kind of guy who wants to just stop and say, hey, I did it. I really tried to offer something that is as with the best quality as possible with the amount of time that I had. So I was like, yeah, probably we can do better. We delivered at time, but we can do better. What if this project now would have been run today, almost 4 years in the future? The first point is the cluster API has become boring, meaning stable, really stable now, highly efficient, tons of features has been added. There's way more providers than what we had back then. I think we're now into 50 providers that has been supported. So it has really opened a lot in what we are capable of with the tool and how we can really leverage it. The clusters template configuration were based on Helm. Now in the cluster API, we have the cluster class and topologies that allows you to create clusters template from the cluster API itself and not from your Helm templates. So you can say, okay, Helm is for my application, and the cluster topology is for the clusters. The main change here is Helm automatically doesn't reconcile. The cluster API does. So that allows us also to have a full control, or that would allow us, if I was able to do it today, to have full control of the full cluster configuration and make sure that if anything happens in between, this configuration will be reapplied. We now have a hosted control plane. I'll talk about it later on. This is a pretty cool feature. We have not yet stable, but we will have in the upcoming releases in-place upgrades. Back at that time, upgrades mean you have to create a new image of your Kubernetes platform, make it available, trigger the upgrade is redeployed, new nodes, move the pods, and so on and so forth. And now we have coming up as an experimental feature, the in-place and chain upgrades. What that means is, for example, I could move from 1.31 to 1.35 at once, single command, locally, without rotating the nodes. I'm just using the same nodes, and the whole system will upgrade the full cluster out of them. Moving from more or less 3 or 4 hours time to 10 minutes. And there's a lot of add-on that comes up. Let's, again, put it for now. How the cluster class moves. This is the Helm, what I did before. This is now the ClusterAPI way. And as you can see, we moved. We're now in V1 Beta 2. Almost GA, stable, fast, secure. Did it. And we have this topology. This topology explains exactly how you can configure your cluster. Name, version, replicas, label, blah, blah, blah. All the add-ons, network, storage, I don't know, ArgoCD, or all the applications stays in Helm. Before, we baked in Helm the application and the cluster, everything in, which was easy to deploy but complex to manage because you are mixing infrastructure configuration with application deployment. Now we're able to separate them. Application, Helm, infrastructure, ClusterAPI, cluster class. Easier. So now you can separate roles. Developers can manage their application, and your DevOps infrastructure team will manage this object. Nobody will mix in with the same files. We now have an operator for the cluster API. It probably doesn't make a lot of sense, and that's fine. This operator is golden. The value of this operator is, if you remember, deploying the operator is clusterctl init. So that's a command line that you do manually. This operator allows you to deploy your cluster API instances automatically on a lot of clusters and manage the upgrades and the system automatically. No more kubectl, no more clusterctl init, and so on and so forth. You deploy the operator, you say, hey, I want to have cluster API there, done. I told you about the hosted control plane. The hosted control plane is probably, for me, one of the best feature that comes up. There's 2 projects I highly recommend you to look at, Cosmotron or Kamaji. Those 2 tools are fully open source, again, and they allow you to move the control plane from virtual machine or physical host to pods. So now you don't deploy, for example, 8 nodes, 3 masters, and 4 workers. You deploy 3 pods in your seed cluster and 5 workers. If you work for a company that is highly sensible in the FinOps way, this helps a lot. And by moving the control plane from virtual machine or bare metal system to pods, that allows you to have a better control of your control plane, but also leverage the feature of Kubernetes itself. Now your control plane is self-filling with HA out of a Kubernetes cluster. Easier to manage. You're losing 1 pod, no worries, it just respawns somewhere. It's not the same as, oh, I lost the virtual machine or the bare metal system's done. And again, that allows you to have another layer of control of what exists in your platform from a single point of view. You really don't have to connect everywhere. You have all the brain system, if I can say that way, local into your seed cluster, single point, manage everything, and redeploy. Very briefly, I'm seeing the clock ticking. As I said, highly experimental. You can play with it. It comes from the version 1.12 or .13, can't remember exactly. My main how could I say, the main value here is to shrink the upgrade time and make it easier. You don't have to deal with, I have to create new image, I have to deploy those image, I have to deploy new nodes. No. I want to move from 1.31 to 1.35, do it. Don't change the node, don't change the IP or whatever. Depending on the company you're working for, I had some clients that have very strict network rules. Even the communication between nodes were secured with firewalls in between. This allows us to not touch anything in the nodes and still offer the upgrades. We don't have to deal with security, we don't have to deal with the network team and so on and so forth. I told you about add-ons. There are couples, actually, I would leverage if I would work on this project nowadays. The first is the Helm provider. Again, no more Helm apply or whatever, no more git pull from the Helm package. This allows you to use Helm as an add-on to deploy application using the Cluster API and leverage all the reconciliation mechanism from the Cluster API. If something is wrong, the Cluster API will automatically detect it and redeploy the package automatically. This is more interesting for the infrastructure point of view, the network interface, the cloud controller managers, or the storage. Again, applications side, leave it to ArgoCD. But again, that allows you to split what's the infrastructure, leave it to the Cluster API, what's related to the application, leave it to ArgoCD. Sveltos is a newcomer, but I really liked it. It's something that comes, again, on top of it. It's an event-driven add-on. Depending on what's happening on the cluster and the labels, it allows you to automate some actions, redeploy applications in several regions, in several clusters at once, just by moving a label from one to another. And it will automatically do it. There's cluster profiles that allows you to reapply some specific configuration on all the clusters at once without leaving the Cluster API to go one by one. While Cluster API goes one by one, Sveltos goes full wide. Again, easier to move. Speaking briefly about Sveltos, I told you about it. One of the features I liked the most, especially for the clients I'm working on right now, is you're able to put it in an air-gap environment. Even if your environment is fully closed, you're able to leverage. It probably doesn't make a lot of sense, but we tend to forget that most of the project that we leverage needs internet connection to deploy, get features, get files, and so on and so forth. This is one of the tools I really like because you have the ability to deploy it in a very closed environment and still leverage all the features. One project, I would stop here and move it briefly. I'm seeing the clock ticking, and I just want to show you a couple of things and have a couple of minutes for question. If you followed me this way, congratulations, very good. And you probably have understood that there's a lot of tools that we're piling up manually. So we have the clusters, we have the operators, we have ArgoCD, we have Sveltos, and so on and so forth, using the Git repository. Everything needs to be built, needs manual operation. There's a human, we can make mistakes, and it takes a lot of time. A new project has been announced, I think this year at KubeCon, is a project called Kubera. Basically what Kubera does is it leaves you to deploy your clusters with the Cluster API project, and everything like ArgoCD, traffic, cert manager, your secret manager in here, which is OpenBow, if I remember correctly. Everything is baked in for you using a template and a single binary. So everything that I did in 3 weeks or 4 weeks manually, I could have done it with 3 commands. Init, generate, bootstrap. 3 weeks to more or less 10 minutes. And this project, well, I think, again, is open source. I encourage you to look at it. The website is kubera.io. It has been open source this year by a company called Stackit. And this is one of the tools that I really liked because, again, it makes things easier, centralized, templated, and automated. Let's see. Let's move a little bit faster and go this way. So how does this work? Easy. You have your infrastructure as code, OpenStack in my case, Cluster API, Kubera, your app's done. 5 stages, 10 minutes, all good. How it works underneath, it has its own configuration, as you can see here. So I can choose the cert manager, the ingress I want to use, if I want to use external secrets or not, which is my policy engine, if I want to use monitoring and so on and so forth. This is the Kubera config file. And once this file has been done, init, generate, bootstrap, done. As simple as that. Technically, how can I enroll cluster that has been deployed by the cluster API into Kubera? Labels. Monitoring true, monitoring true. I just have to add the same label in both spaces, and it will automatically sync, and then Kubera will enroll the CAPI cluster and deploy, in this case, the monitoring features of Kubera into the cluster that has been deployed by the cluster API product, just by using labels. Or to summarize, that would be the first, the full project that I would have go in if I was working on this project nowadays. The infrastructure at the top, OpenStack for all the features that I need, internal image mirror because RGAP, Git repository, creds, done. And you have a quick example here that allows you to see how it works. Basically, you create your kind cluster, you deploy the cluster API project, apply the configuration, bootstrap, label, done. To summarize a little bit and open for questions, you have on the left what happened to me 4 years ago. Here's what I would do today. Back then, I heavily leveraged Helm templates because I didn't have anything else to work on. Everything was pure VM. The upgrades was rolling, so like nodes by nodes. ArgoCD was deployed manually. I had to write a couple of YAMLs. If I want to do it today, I can leverage the cluster class, the operators, probably the hosted control plane, and then I have the ability to switch between either Kubera, as I told you, or vCluster if you're into the vCluster side. Key takeaways. We can use Kubernetes to deploy Kubernetes and do even more. I think I have convinced you about this. This project, this ecosystem around Cluster API opened a lot of features. Not only Kubernetes, but there's a lot of interaction that you can use to move the whole platform from one provider to another, deploy application, deploy several instances of your production platform in different regions at once. If you're into a company that works on different international regions, you have this ability. You don't have to do it manually. You just tell the Cluster API project for the infrastructure and Kubera for the engineering stack, just deploy it, and it will automatically deploy in region A, B, C, D automatically. Dev can manage their clusters. They don't need me anymore. They don't need any platform engineer. Just a commit. You just create everything, put it in a Git repository, commit, done. And as I said before, tools like Kubera, at least for me, I think really lowers the entry level of that kind of projects. You don't need to know everything about the infrastructure, network, security and stuff. There's someone like me who prepares the whole stack, make the template, put it in a Git repository, couple of documentation. A README file is more than enough. Leave the developers to do your Git commit, and you're good. I have 5 minutes left. Either I go to a quick demo or questions, whatever you want. Is anybody has question perhaps so far? 1, 2, 3. Okay. No one? All right. Quick demo. So this is what we did, or this is what I would do. So we're, oh no, sorry, you're not seeing it. Where am I? There we are. All right. Sorry. So we create the cluster locally with a file that is the current configuration. The node is deployed. You see that current is deploying everything. I'm doing the cluster init. In my case, it's the Docker infrastructure because I'm working on this demo locally on my machine. Again, there's couples of infrastructure provider that you are able to leverage. Docker is the simple one, but you can use OpenStack, AWS, Azure, Google, OVH, Scaleway. There's a lot of them. It's really up for you to choose. As you can see, the management cluster is ready. And now it tells me, oh, if you want to deploy your very first cluster, here's how you do it. kubectl, cluster, CTL, generate cluster, blah, 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 and then apply. And this is what I did. So it created for me a simple file with a flavor, development for Docker, a version, how many control plane I want, how many workers. In my case, none, because I wanted to make it easy. And that's it. There we are. I have my 2 clusters ready here, locally, and now move on to Kubera. As I said, init, bootstrap. And as you can see, it deploys a lot of stuff. I have OpenBow there, ArgoCD, the shirt manager. I have traffic that has been deployed as a load balancer. I haven't done anything. Kubera manages everything for me automatically. And we're done. Kubera bootstrap completed. Here's how you can connect to your ArgoCD or your Grafana, blah, blah, blah. Here's the login, and I can switch to them. And as you can see, I have my clusters ready. Done. More or less 5 minutes. And now, time for questions. Thanks for joining this talk. I hope you really like it. If you have any questions, then please raise your hand. We have 2 minutes, I think. Please give some feedback. This is a new talk I've been working on, so I'm really eager to get as much feedback as possible to improve it, if any. And again, open for questions if you want. Thank you. The question.
It's more an understanding question, so I get that right. Kubera deploys ArgoCD and all the tools in the destination cluster, so to say. How does the user who requested the cluster knows where it can access the Argo installation, and how is the Git onboarding as well on that, because you need some repo where it deploys from, right? So how is that part done, or would be done, I guess, because you...
You mean how Kubera deploys the ArgoCD and how to access it?
Yeah, how the user knows how to access it, and how the user configures which repo would be deployed in that cluster with their applications, you know?
Kubera leverages some templates. Let me see if I can show you briefly. I think I have something like, let me see. There we are. So these are the templates that Kubera manages to deploy the whole stuff. So when you do your init and bootstrap, it creates automatically in the Git repository all the configuration file that it needs to deploy the whole stuff. And then it starts by ArgoCD and then asks ArgoCD to deploy the rest. So looking for the ArgoCD configuration, for example, we have it here. And that's the Helm template. So you can change the configuration from this template and then apply it everywhere you want, if that's your question.
I think I will take it offline. Thank you.
Anyone last question? Nope. Can we do I don't know how to say it in English, I'm sorry. I just want to hear from 1 to 5 how you like this talk. So just raise your hand and do the 1, 2, 3, 4, 5, whatever.
5.
Oh. Oh. Thank you so much.